Hi Algebra 1. We're going to continue working through Chapter 8 today. I've got a brand new week ahead of us, new lessons to learn about multiplying binomials, and we're going to move into factoring this week too. Today's lesson though, first will be more about multiplying binomials. And today what we're going to focus on is a certain type of pattern to follow. You're going to be able to recognize a certain pattern when we multiply binomials today, and the purpose of the pattern is to make it easier and is to make a shortcut for this work. Now, I'll probably say it a few times during this video, but if you forget the shortcut or the pattern, you will still get the right answer if you use any of the three methods we learned last week for multiplying binomials. For example, if you forget the patterns that we're going to go over today, and you decide to just use the FOIL method or distribution or the chart, you will still get the same answer in the end. The purpose of the pattern is just to make your job easier. Okay, so today you should be in your books on page 492, and you should have at least looked at the note handout for today and have either that printed out or paper and pencil so that you can take notes on what I'm going over in this video. And excuse me, I want to just show you what I have written here on the board. We have two patterns that we're going to be talking about today. They are two versions of the same pattern, actually. We are going to be discussing the pattern or the shortcut method to squaring a binomial. Now, as we've been learning throughout the last few lessons, a binomial has two terms. So in these problems, we are going to have one quantity with two terms, and it's going to be the quantity squared. So that's why it's called a binomial squared. And this is the pattern that we will be applying today. The A refers to whatever is in the first position inside our binomial. The B is referring to whatever is in the second position. You'll notice that one deals with addition, one deals with subtraction, but they are very similar otherwise. What I want to do first is just show you this example here on the bottom. I'm going to show you where this pattern comes from. So if I have this binomial here, x plus 4, and I want to square it, I want to square the entire quantity. This does not mean I simply raise everything to the second power inside the parentheses. That is not correct. That is totally different than the power rules that we learned last week or 2 weeks ago. The reason it's different is because this quantity is being added. They are not being multiplied, they're being added. So please, please pay attention to that distinction. I do not just simply raise everything to the second power when it's a binomial. And I'm going to show you why that's different. If I didn't know the pattern yet, and remember, I'm going to talk about how we get the pattern, I would write this out as x plus 4, and the quantity is being squared. So I'm going to multiply it by itself twice. So then I have two quantities of x plus 4 being multiplied. Now remember, you have three methods to do this. You've learned all three. I prefer the FOIL method, so whenever I demonstrate, I'm going to use the FOIL method. My first would give me x squared, my outsides would give me 4x, my insides 4x, and my lasts would give me 16. Then I would see here that 4x and 4x are common terms, and they can be combined. They have the same variable, same power, so I do the math of the coefficients, and I get 8x. Remember, when we multiply two terms by two terms, we get 4 terms. And then we might clean up and end up with 3. Okay, so my final answer here to squaring x plus 4 gives me x squared plus 8x plus 16. And so this is we end up in a perfect square trinomial is what we call that, because it is the result of a perfect square, the binomials being squared. Where we see the pattern here is, like I said, my A is whatever is in my first position. So in this problem, it's an x. So according to this pattern, I would square that, and I get x squared, just like I did here. Then I take my A times my B and double it. So in this problem, a times my b is 4x, double it gives me my 8x. My last part of my perfect square trinomial is just the b squared. My b is my second position, 4 squared is 16. So this is offering you a shortcut method to be able to perform binomials squared. The only distinction that I want to make is, notice when we are subtracting, right here, I end up getting a negative outside and inside term, which would give me a negative middle term here. But then when I square a negative number, I will always end up with a positive number, because of multiplying a negative by a negative gives me a positive. So the only difference between these two patterns is this sign if it's adding, this sign if it's subtracting. Okay, let's go ahead and apply these patterns. And again, remember I said the benefit of these patterns is to make your job easier. So you should be able to just apply mental math at this point. But when in doubt, revert back to FOIL and you will still get these answers correct. Okay, so we're going to do these two problems together, and then we have two practice problems before we go on to a geometry word problem that uses this scale. So I moved the pattern off of the screen. You have it in front of you in your textbook or on your note handouts, or you should have written it down on paper if you're taking notes that way. So the good news is I have it memorized, which you will too. Okay, so my first problem, x plus 8 quantity squared. I know that that does not mean I have x squared plus 8 squared. That is incorrect, completely wrong. So I notice that this first term would be my a in the pattern, first position. The second one would be my b. It's in the second position. So if I apply the pattern, my first squared plus multiplying these two together and doubling it, and then squaring my second term. And there it is. Notice how that saved 2 steps for me, where I had to get all 4 terms and then clean up the common terms. It saves me time, makes my job easier, but it's a shortcut. So if you forget and go back to FOIL, you'll still get the same answer. Let's move on to the next one. What makes the second example a little bit harder, which you may have noticed, is that I don't just have one item here in my first position. I have 2 things together. It's okay. The pattern still applies. So I'm going to recognize that this would be my A, because it's in my first position, and this is my B. So according to the pattern, it's going to be subtraction. So it's going to be my first squared. And notice I'm writing it this way. I'm showing you this step that you can probably get to the point where you're doing that in your head, but I want to show it to you on the board, and then you can see how I'll clean that up in my next step. Then I multiply these two together, and that would give me negative 6m, but then I double it. And then my last is squaring that second position. Here, I have 2m being squared. This takes me straight back to chapter 7, and we have problems like this on the test. I know I square the 2 and I square the m. So what I really have here is 4m squared. And that's the answer to squaring this binomial. And I did those using just the patterns that we are studying today. Okay, at this point I want you to pause the video and I want you to practice these 2 problems. They are in the note handout, as well as in your book under the Got It problems for problems 1 and 2. So pause that and then restart it when you're ready to go over the answers. Okay, again, I'm going to just use our patterns for this. The first thing I need to do is recognize that this one is going to follow the subtraction pattern. And this n is my first position. This 7 is my second position. So based on the pattern, which you probably don't have it memorized yet, and that's okay, it's in your book and your note handout. Be my first term being squared, then I multiply these together and double it, and then I add the second term squared. This is my answer for the first practice problem. The second one looks just like the first one we did together, treating this 2x together. So when I recognize that that's my A and this is my B, and I'm adding, so I'm going to follow the adding pattern, I get 4x squared plus 36x plus 81. Again, following the pattern. My first term squared, my first times my second, and then doubled, and then my third squared. Okay, so what we're going to do next is we're going to apply this pattern to a geometry problem. So I'm going to clear my board, and while I do that, I want you to make sure you are in your books on page 493. There's a word problem there and a nice picture. I'm going to replicate that picture on my board, and we're going to solve it. Okay, so in this problem, we are told that there is a patio, and that's my inside square. In this patio is outlined by a brick walkway. In the dimension of this brick walkway, and let me get to the right page, we are told that this brick walkway is 3 feet across. So I'm going to put it that way. They give me the dimensions of the patio as x by x. So I know that if two sides are the same, that all 4 of these are the same, and I'm told it's a square in the problem anyways. Okay, so this brick walkway is 3 feet around the outside of a square patio. The question is asking though, what is the area of just the walkway? So I'm going to use a different color and show you that part that we are trying to find. This part in green is the area we're trying to find. So anytime we have a geometry problem like this, where we want to find the portion of a shape, we follow this pattern. We want to take the whole minus the part. So in this case, I have the entire shape here, and I have this inside shape. And if I subtract the entire area minus the inside area, I'm left with just the walkway that's all going around the square. Well, this is where our squaring binomials comes into play. I noticed, first of all, that the area of the inside square is x times x. So I find the area of a square. I square it. So I would call it that. So my part that I'm going to subtract eventually is x squared. That's the easy part. The harder part is figuring out what's the area of everything all together. So if I know this measurement is x, and I know this is 3, I also know this is 3. So one dimension is x plus 3 plus 3, because there are 3 feet on either side of it. So that tells me that it's actually x plus 6. Well, I know I'm dealing with a square, but I can also tell that from looking at a picture. Again, I have x plus 3 plus 3, so this part is also x plus 6. And how do I find the area of a square? I square one side. So you can see where squaring the binomials is coming into play here. So I first need to square this binomial. Then I'm going to subtract the x squared for the inside of the patio. Using my pattern, again, this is my A, and this is my B. X squared plus 12x plus 36 is the area of the entire shape of what we're talking about. My first term squared, first times second and doubled, second squared. Again, just using my pattern. And I know I'm going to subtract the x squared of the inside portion here. So whenever I do x squared minus x squared, look what happens. They cancel each other out, leaving me the area of just the walkway around the patio is 12x plus 36. What? Remember, we're dealing with a word problem, so I need a unit. We're talking about feet in the problem, and it is an area, so it will be squared, square feet. Okay, what I want you to do is pause the video, and you're going to try the practice problem. It's in the note handout. It's also under the Got It problem for problem 2. And what it is asking is actually solve this problem again, but as if the walkway were 4 feet wide. So you're just going to apply this same exact process, but it's going to be 4 feet instead of 3 feet. So I'm going to change that up while you pause this and do the problem on your own. Okay, I'm just adjusting my picture to show that my walkway now is 4 feet across. My process is still going to be exactly the same. I'm going to take the area of the whole shape and subtract the inside to get me the area of just the walkway around. Well, in this case, the area of my inside actually hasn't changed at all. That still is x squared. And that's what I'm going to subtract from the entire area. Well, just like we did last time, we could tell that one side of the whole shape would be this x plus 4 plus 4, because it's 4 feet on either side. So we're now actually dealing with this binomial, x plus 8. Same thing on this side. I know that just because it's a square, and also I can see it from my diagram. We have an x plus the 4 plus the 4. So in this problem, I'm going to square the binomial x plus 8. I'm going to use my pattern again. X squared plus 16x plus 64. That's the area of the entire shape. Then I'm going to subtract from that the area of the inside patio. Oops, x squared. Find my common terms. My only common terms are my x squared. That's gone. And again, in square feet, because we're talking about an area. 16x plus 64 is my answer to this practice problem. Okay, at this point, I want to insert another possibility here for extra credit for those of you who are watching my videos. What you need to do by Tuesday afternoon at 5 o'clock when this assignment is due is to just send me an email with the name of your favorite Avenger. And that's all you need to do. That will be my way of knowing that you are watching the video and you can get extra credit for that. If you look at the note handout for today's lesson or on RenWeb, you can see the suggested book problems on page 495 and the one Khan Academy assignment that corresponds with this lesson. Okay, both the extra credit and the Khan Academy assignment are due Tuesday at 5 p.m. Have a great day.